Let's go through question 2 on the practice SAC. This is about really being able to apply your knowledge of the electrochemical series to work out where these mysterious metals would go on the electrochemical series in relation to each other. So what we need to be doing is we need to be seeing, okay, we have a strip of Y, highlight here, is placed in XNO3. Most of the strip had disappeared by the morning. So obviously, Y solid, and I'm really going to just write these out, not as proper half equations, but just to illustrate my point, Y solid has gone to Y plus. And again, this is not the actual charge. The charge on Y is 2 plus, but I'm just going to write them all out like this. Nice and simple so you can get my gist and I can move on quickly. So, Y is placed in X. We see a reaction, most of the strip has disappeared. We've got solid going into aqueous. That must mean we have Y solid as the strongest reductant, therefore it's lowest down on electrochemical series, and we've got the reductant on the right. That means our X, with its positive charge, must be therefore higher up on the electrochemical series, and we'll do this as arrows going both ways, or technically we do the reversible arrows like this. So we've got Y below X on this mini electrochemical series. Then we need to know, where does Z go? Well, when a strip of Z was reacted with Y, no reaction occurs. That implies that these were the conjugates, and therefore solid Z must be higher on the electrochemical series, so it's not the strongest reductant, so it's higher than Y. And Y aqueous must be lower than Z aqueous, or Y ion must be lower than Z ion on electrochemical series, so it's not the strongest oxidant. So we know Z has to either be above Y or above Y and X. Third, when a strip of Z was placed in XNO3, a reaction occurred. So again, the strip of Z must be the strongest reductant, so it must be below the strip of X, and X ion must be above the Z ion. So here, I've worked out from these 3 observations where they all sit in relation to each other. So, write a mini electrochemical series. The actual way you'd obviously be writing it out is, if we've got X first, it's X 2 plus, plus, well, 2 electrons, of course, to then make X solid. Of course, you can put X aqueous in here. I just don't have the dexterity to properly write this, but we'll give it a go. There we go. That just looks like a weird QG. Okay, writing it out like that, doing it for X, doing it for Z, doing it for Y. There you go. Also, I will note, yes, the marking is a little bit funky on this practice SAC. I didn't actually set the marking. I think a lot of these questions would have more marks assigned with them. And I am adapting your full SAC, so the marking will be exactly as I'd expect it to be. So this then comes back to A. Write a balanced chemical equation for the reaction between Y and Z nitrate. What we really need to be focusing on here is, so we're going to have Y solid plus Z. What is it? Down here it says it's 3 plus, and that'll be aqueous. And we are going to produce, we know Y, what charge? 2 plus, Y 2 plus aqueous plus Z solid. What we need to be doing is we need to be balancing that charge. So if this is 3 plus, this is 2 plus, not balanced. What we need to do is we need to have 2z, 3y. So we know what we have. Therefore, between y and y, we're going to go loss of 6 electrons between z and z. We will have gain of 6 electrons, and then that's a balanced overall reaction. Okay, so I think that clears up most of what you have to do with that, especially the logic of what you have to do for writing that mini electrochemical series. This is definitely something that I might have you doing in your actual SAC. So make sure you understand it and make sure you talk to me if you don't.